Hi everybody, this is Cal with a video reading guide for section 12.1, three-dimensional coordinate systems. A note for those who are just starting out with the reading guides. What these are is just a way to lead you through the reading. I'm not necessarily going to go deeply into all the material, but I am going to point out, what's important, what's not so important, might occasionally answer an IRAT question. So hopefully this is a good resource to help you with the reading, because I know that reading a textbook can be a little bit difficult if you haven't been doing it for a long time. So we're going to talk here about section 12.1, our first section for this course, three-dimensional coordinate systems. And this section is just an introduction to working in three dimensions. It's going to get some notation underway and just introduce a couple of concepts that should mostly look relatively familiar from other classes. If this is your first time working with three-dimensional coordinate systems, then you might need to work a little bit harder than students who are seeing this for the second or third time. We start here on page 810 with basically some nomenclature. We talk about coordinate axes, the right-hand rule, and the illustration pretty much says the whole thing. It talks about how the x, y, and z axes relate to each other. Right-hand rule will come back in a bigger way in a few sections, so don't just totally ignore it. They talk about coordinate planes, the idea of octants, and in particular the first octant, which is where all the variables are positive. The book talks at the bottom of this page about how to visualize things in three dimensions and kind of how to draw points in three dimensions. You can see that in figure 4. And visualization is going to be very important to your understanding in this class, so make sure you start early and develop your visualization and your drawing skills as early as you can. Okay, the book talks about coordinates of a point. That should be a familiar idea. And here at the top of page 811, we have some more discussion of how to draw points and projections of points onto planes and onto lines. Make sure that you do understand this picture and what's going on with it. Let's see. So we talk about R3 as a three-dimensional rectangular coordinate system. I don't know, there's a heck of a lot to say there. Example 1 gives a couple of common surfaces in R3. Make sure that you do follow through this example and kind of see what's going on over here. It goes on to the next page. Example 2 gives you an idea of some slightly more complicated surfaces in R3. And we'll get into surfaces in a deeper way later on, but do read this example. Finally, example 3 is a pretty good one, so make sure that you're familiar with that. At the bottom of page 812, we have the distance formula in 3 dimensions. This should look relatively similar to the distance formula in 2 dimensions. It comes from the Pythagorean theorem. And you absolutely need to know this distance formula. This is going to come up over and over. The proof of it is at the top of page 813, and you should read through it. It's a reasonable proof. Example 4 gives an example of using the distance formula. It's pretty straightforward. Finally, example 5 says to find an equation of a sphere with radius r and center hkl, and they just use that distance formula, and you should see if you can follow how that works. The result, the example they have in this box here, equation of a sphere, and that'll come up a little bit. Example 6 shows how to simplify an equation that might be given into this basic form in the box. Take note of example 6. If you haven't completed a square for a while, this is a good reminder. So make sure you still know how to do that. And example 7 gives an example of an inequality in 3 dimensions. And I think that's basically it for this section.